Hey guys, welcome back. We're going to do a quick little video just to summarize all the titrations so that we get everything down and hopefully it's rock solid. And so we're going to have the fraction titrated, right? Strong acid, strong base, doesn't, right? And strong acid or strong base and weak acid. Now, most of the examples we do, the strong base is the titrant, which is in the burette, and the acids are in the flask, the analytes, right? But it works either way, okay? So the initial, before anything from the burette is delivered to the flask, before anything, right? We're set up, what's the initial pH of the analyte solution, right? And for strong, the pH is due to how much strong acid or how much strong base you have if it's 1-to-1, right? What do I mean by that? Well, for example, H2SO4 is not 1-to-1, right? If I had BaOH2, that's not 1-to-1, if that makes sense, right? There's two hydroxides for every barium, okay? So the concentration of hydroxide would be double the concentration of barium hydroxide. All right, but assuming that you have whatever you like, most of the time we'll do HCl or HNO3, right? Even the strong weak, it's the same thing. You got Ka, Kb. If you had H3PO4, it's gonna be slightly different than if you had HCOOH, right? With this H coming off, and so just note that most of the time this is for 1-to-1. Okay, 1-to-1, one acid, one base, one proton donating, one proton accepting. All right, so strong, it's strong acid, pH calculation. Strong weak, it's either a strong or a weak acid or a weak base calculation with the ice table. Once we start adding, right, so now you open the burette and you start adding, all right, before the equivalence point, all right, so you got a quarter, half, 3/4. The pH in the strong is always due to excess strong acid in the flask or excess strong base in the flask, whatever the analyte is. In the weaks, we now have the buffer. All right, so you use the Henderson-Hasselbalch equation to this whole region to solve what the pH is. However, at halfway, the pH is the pKa. All right. Now, at the equivalence point, right, where the moles of acid equal the moles of base, right? Moles of acid equal moles of base. pH of the strong should be 7, theoretically, right? And then strong weak, we got hydrolysis here, right? So the hydrolysis of the conjugate, whatever the conjugate, if it's an acid or a conjugate base, right? And so whatever reacts, you have a weak salt that's going to be either a proton donor or acceptor, and that's going to change the pH. Then finally, past equivalent, right? Typically we mark 1 1/4, but it's just anytime we're a couple drops past the equivalence point, the pH is due to the excess titrant. So from the burette now, for both of these, right? The pH is the same calculation for both. There's no difference, all right? So that is the summary of how the strong and strong weak titrations are kind of calculated, what region you're in, what to do. Hopefully that reinforces what we've already talked about. If you have any questions, reach out. Otherwise, we'll see you next time, guys. Take care.